Hello there. Yeah, good morning, good afternoon, good evening, whatever it is in your time zone for those of you watching this live. A warm welcome to day 2 of the Windows Phone, Building Apps for Windows Phone 8.1 Jumpstart. I'm Andy Wigley, and I'm a technical evangelist working out of the UK, in case you missed the introductions from yesterday. So just to tell you again, I've been working with mobile for over a decade. I was there in the early days of the Silver Surfer on the WAP thing, and then I've worked with ASP.NET Mobile Controls, Windows Mobile and Windows CE, and obviously more recently Windows Phone, the latest and greatest generation of Microsoft-powered mobile devices. So I've done a few jump starts before, and today's trivial fact about me is, yes, I am a rock star because I not only play rock music, I also like rock climbing. And allegedly, I'm also a character on Game of Thrones, although I'm not sure about that one. With me is Matthias.
Hey, I'm Matthias Shapiro. I am a program manager and technical evangelist at Microsoft. I've been doing XAML development of all sorts, all flavors, WPF and Silverlight and Windows Phone, pretty much my entire career, which is not really very long. But I was there at the beginning of WPF, learning all that great stuff, and kind of have transitioned from the designer side of things into a more formal developer. All that time I've been a blogger, a demo writer, and just generally a noisemaker. I like to play around with all sorts of different devices and connect them to other devices and make them all do crazy things. So I've been with Windows, doing the Windows Phone stuff since the beginning, and I'm super excited to be a part of the Jumpstart.
Okay, so if you this was the agenda from yesterday. So if you're joining us just joining us now, don't worry about it. This sort of stuff everything obviously is being recorded and will be up on Channel 9 and as a MVA, Microsoft Virtual Academy course. So yesterday we had the introduction and a sort of a mini course. That purple-hued stuff there was all a mini course on building Windows Runtime XAML apps, which is the new XAML stack that we've got on Windows Phone 8.1 alongside the Silverlight XAML stack. So that was what we had, and we wrapped up with a deep dive into data storage and data roaming and sharing contracts, sharing files, file pickers, and open file pickers, which are surprisingly interesting for something. So yeah. I mean, it's good. And then today, we've got loads of really cool stuff for you today. We're going to start with a quick look at background tasks and multitasking. We then got another session on maps and geofencing. Then we're going to look at Azure Mobile Services and networking topics, tiles, notifications, and Action Center. And that will take us up to lunch here on the Pacific Northwest. And then after that break, we'll have a meal break, and then we're going to look at sensors and proximity. So proximity is loads of cool new stuff with NFC and Bluetooth LE. So that's a really nice session. Then we're interacting with user data, contacts and appointments. But actually, the key topic in there is email with attachments. So there you go. Yeah. And then we got a detailed session looking at there's loads of cool new stuff with camera and video. So Matthias is going to take us through that. And then Matthias is going to morph into Matthijs, another Matt. We're going to have a guest speaker come in, Matthijs Hoekstra, who's going to take us through Enterprise for Windows Phone 8.1. I'm going to give you a quick look through programming SQLite, and then we'll wrap up today's agenda with tooling and diagnostics. We have another half day coming tomorrow, so if you can join us for that as well, that would be cool, where we look at the store, interacting with the store, in-app purchase, submitting your apps, and the whole process you go through for that. Then we'll have a kind of more of a detailed look at building universal apps. One solution, creating apps that will run on Windows Phone and on Windows Tablet PC. Then we're finally, and it's last but definitely not least, we've got a session specifically aimed at our Silverlight app developer community, looking at how you can take full advantage of all the great new features in Windows Phone 8.1. And you can. All these Windows runtime, all the content we're talking about today, everything is available for both Windows runtime XAML apps and also Windows Phone Silverlight apps. All right, so let's get started with the first session of today, which is we're going to look at background tasks and multitasking. So in this module, we'll look at what is the multitasking on Windows Phone, how you actually build a background task and what you use to get them to run, which are triggers, the conditions on background task execution, and we've got to look at a little example at the end. So first of all, let's look at the mobile multitasking model. So the first thing, obviously, you have to realize about any mobile device is that resources are constrained. Battery power is the most valuable resource that we have in mobile devices and is the one that has to be protected above all else. What this means is that we have this kind of, all of the mobile OSs are all work the same way, in that any app that is not visible and not being used by any foreground app, not being used by the user at any one time, is suspended. This means it's not using resources, it's not burning battery, it's not running the CPU. This is crucial, obviously, for making sure that that battery goes as long as possible and that the user gets a great user experience and gets the app that they're interacting with at any one time, gets the full resources of the phone, the CPU, and everything. But everything else, they can resume those apps very, very quickly, and it looks to them as if they've been running all the time, but in actual fact, they've been suspended. But of course, when an app is not actually visible, when the user isn't actually interacting, there are lots of ways how it can still interact with the user and give them useful content. One way, obviously, is by updating live tiles or sending toasts. And you can do that both from sort of APIs. You can schedule things to come up when the user is using the foreground app. You can schedule toasts and tile notifications to happen at some point in the future. But the more usual way of doing that is to send notifications through from your back-end system. So you can send push notifications through and use them to update tiles or toasts. But either way, what you're doing is giving that user up-to-date information that's relevant to them. Scheduled toasts, these are the ones that I'm just talking about, where you can set a time schedule where these are going to turn up. And Matthias is going to talk about that in more detail in the very next, session after next. And we have OS broker tasks, which this is the subject of this particular session, where we've got the operating system will run some background code for you under certain conditions, assuming it's got sufficient resources, like its battery isn't dying, and you've programmed for a certain condition to happen. The background tasks and agents is what is the key one around this, which is background execution tasks, which will be executed on certain conditions, like timers or time zone changes or all sorts of kind of conditions. A quick refresh on what we had in Windows Phone 8. So in Windows Phone 8, we had scheduled task, which was two types of scheduled task, a periodic task or a resource-intensive task. And we also had the background transfer service and the background location tracking. Now, periodic task and resource-intensive task, the periodic task, the OS would run that roughly every 30 minutes or so, assuming the battery wasn't into battery saver mode. And you could execute some code for around about 30 seconds or so. Resource-intensive task, you can run for like 10 minutes, but you have to be actually plugged in on charge, and the user isn't actually using that device at that time. So two ways of doing stuff in the background, but perhaps a little bit limiting for some scenarios. So we've got these other ones, the background transfer service for transferring files. We've got a new WinRT API that we will look at in the networking session later this morning. Then we got background location tracking and voice over IP and audio agents running in the background. So let's have a look now at what we've got with Windows Phone 8.1. So first of all, an app can register background tasks. They are actually executed, scheduled and run by the OS. The OS is responsible for running them in its own process. But they are, and should always be considered as, they are background extensions of the foreground app. You create them in the same solution. They have access to the same local folders, the app data folders. Same file access, so same storage area, and they're subject to the same permission. So stuff you set in the manifest obviously applies equally to the foreground app as it does to what's happening in the background task. With all of these things, resource usage is constrained by the system. So, you haven't got free reign to just run amok and have this crazy background task that's running for tens of minutes and using loads of resources and throwing out push notifications left, right, and center. You're just not going to be allowed to do that. But what you are going to be allowed to do is really valuable work that will allow your app to live on, if you like, when the user isn't actively interacting with it as the foreground app. If the foreground app is running at the same time as its background task, which obviously may or may not happen, but if it is, you can actually communicate between the two. The background task can fire progress and completed events, which the foreground app can subscribe to, so it can be notified of the progress of your background task as it's executing. And like we said, we've got the same storage as the foreground app, so they could read and write from the same files and as a way of communicating between the two of them. And of course, tasks can use Toast, Tiles, and Badge UI, so they can immediately kind of interact with the user by putting out these visible things like Toast put notifications, Tile updates, and Badge updates. And any app can query what task registrations it can have from the system. And the important thing is, obviously, an app here can have more than one different kind of background task. So you can have different ones that are firing for different circumstances. So it's much more flexible than what we had in Windows Phone 8.
One thing I think about the resources that is worth calling out is that a lot of the resource constraints are around CPU seconds instead of being around physical seconds. So if you do need to make an HTTP call, you can do an async, and then while it's making that call and waiting for the server to respond, that's not actually taking up the resources that you're using.
Yeah, so it's an improvement on the old.
It's a massive improvement. It actually gives you a lot more time than you might think.
Yeah. So, okay. When you're creating a background task, this is how you add the background task. So I'm going to focus on building out that background work first. You need to add a new project to your solution, and the project type needs to be this Windows Runtime component. So you're just going to add new project and choose the appropriate template, and that will give you the right kind of project that will spit out a DLL which will be executed by the OS at the appropriate time. Once you've created that background task project, you probably want to add a reference to it. You will need to add a reference to that project go into your foreground app project and add reference, and just point at that newly added background task project. Inside the background task, you'll get this. You'll get an empty public class when you create one of those components, and you need to go into that and edit it, so that it inherits from iBackgroundTask. It needs to implement that interface, the iBackgroundTask. iBackgroundTask just has a single method defined in it, which is this run method. So you implement that interface, so you create this run method, and inside there you put your logic. So first of all, if you're doing any async stuff, you first of all need to get a deferral. Then you do all your work. And we don't actually show any work on this particular slide here. And then at the end, you call deferral.complete. You've got this two events that you can handle within the task. First of all, this instance.cancelled event. If you subscribe to that in your background task, while you're running, you might get sort of cancelled in a clean way. Now, it's important that this is why I've called this out. There's an important thing to notice here, that you might get a cancelled notification from the OS if the foreground app has cancelled the background task, or it's a clean cancellation, if you like, which is possible. In which case you'll get this event fired, and you can kind of do a clean shutdown. But in actual fact, on Windows Phone, if you exceed the memory cap, and I'm going to come on to that at the end of this session, how much memory you've got, you'll just get killed, terminated rudely, as we say. So you should just write your background task expecting that you might be terminated rudely if you get things wrong. So if you code for that, you're going to be in a good place. Then there's also a thing shown on this code is the instance.progress equals, and it's shown as 0 on the code slide here. Just below the blue dash there, instance.progress equals 0. So that's just a progress counter. You just set that property to a 0 right through to 10, and that communicates to the foreground task, and the foreground task can subscribe to the background task's progress reported event, and that will then you can get a kind of a progress count of how far through its work it is, which you could choose to show as a status bar or some kind of information in the foreground app UI if it happens to be running. Okay, so that's how you create the background task. How do you actually schedule these things to run? Well, it's all about this thing called triggers. So triggers are OS things that fire, and there are loads of them. Tasks run in response to a trigger. There's a broad category called system trigger, and the system trigger has loads of different kinds of flavors of it. So the user present, user away is, let me just find the right thing here. The user present, user away is linked with when the screen goes on or off on Windows Phone. The network state change one fires when the network changes from cell to Wi-Fi or from present to not present. Internet available, well, that's kind of self-explanatory. That fires when the internet it becomes available or goes away. Session connected fires when the phone boots up. The servicing complete is actually quite an interesting one. So this is when you install an update to your app. So and remember, this happens on Windows Phone 8.1 silently. So the app installation, the app update will get installed. And then at that point, if you've registered for this servicing complete trigger, you can run a background task. So you can do some sort of, upgrade the data, the stored data, if you like. That if your upgrade requires some changes to the state, the persistent data for your app, you can do those changes in the background before the user even runs the app again. So that's an interesting one. Time zone change, of course, when you switch time zone. And then there's a couple there that are noted: lock screen application added and removed. They're not supported on Windows Phone. They are very important on big Windows. But actually on Windows Phone, background task execution is not linked in any way to this concept of an app being pinned to the lock screen like it is on big Windows. So for Windows Phone, you can just forget all about that. Going down the first one, the next one's in here. The time trigger, obviously, this is one that you just set a time interval and it will run a period. This is the same, actually, as the periodic task we had on Windows Phone 8. Minimum time interval is 30 minutes, but every 30 minutes you can kind of do some work.
Yeah.
Location trigger is all about triggering when a user enters or leaves a geofence location. Matthias is going to show us geofencing in the next session. Maintenance trigger, this is similar to the resource-intensive task for Windows Phone 8. So this is when you're when you're actually on charge, and you can do some pretty major work in a background task when the user isn't using it and you're on charge. Push notification trigger is super interesting as well. This is really one of the most exciting new features, I think, in Phone 8.1. You can now send a raw notification from your back-end systems, from the cloud or from mobile services or whatever, and that can be used to trigger some background execution. So you can run some code when a push notification comes in, something you couldn't do on Windows Phone 8. So this is really cool. I've actually got a specific example we'll walk through on that towards the end.
Yeah, no, I'm particularly excited about this because maybe for everyone who doesn't know, a raw notification, most of our notifications have a structure to it. A raw notification is like just a string. You can send just a string as a notification to the system, and the background task will pick it up, and you can kind of do whatever you want at that point.
Yeah.
So,
it's cool stuff. We've also got a bunch of triggers to do with Bluetooth. I'm not going to talk a huge amount about those here because we have a session on Bluetooth and we will come back to those. But essentially when a Bluetooth LE device connects or disconnects, you can run some code, and that really allows you to create really exciting apps that are interacting with Internet of Things kind of stuff. So like I said, we'll come back to that in the Bluetooth LE session later on. You can also put conditions on these. So not only the trigger, but you can also add a condition. So you can say, okay, when this trigger happens, and also the internet is available or not available, or actually background work cost not high. So you can kind of say, well, run this if the system's not kind of busy, which is a nice thing that you can do for your user. so these conditions can be applied as well. And the way you do that is, we'll look at the specific code in a minute, but you use this background task builder is the key object when registering a background task, where you add the trigger, and you also can then add this condition. So there's an example at the bottom saying, okay, I want you to run this background task on this trigger and only when the internet is available. So that saves you not trying to do something in a background task where it's clearly going to fail because you need the network or something like that. You need to declare any of these background tasks in the manifest. We've got a single instance shown here where you go into this bit on the left where you have your supported declarations. You add background tasks, and then you have to set for each, and you can add multiple background tasks. So you can have 1, 2, 3, or whatever of these. I don't actually know what the maximum number is, but for each one that you add, you then have to set in the properties what kind of trigger it is. So system event is that broad category with all those subdivisions in it. Then there's other different ones, audio control channel, push notification, location. Control channel is actually not supported on phone. I think that's probably an old image. Then at the entry point, you've got to put the name of the project. My background task is the DLL of this is your background task DLL. And then you need to put the name of the class in the background task. So when you added that Windows Runtime component, it needs to be the name of that project dot the name of the class. And you can add multiple background tasks to this. You don't actually need to specify anything in that executable box. So here's a key thing as well, and this is true, obviously, again, this is all converged, same code on big Windows as it is on Windows Phone. You need to call background execution manager.request access async, and you need to do this on both. But actually what happens on Windows tablet and PC compared to Windows Phone is somewhat different at this point. On Windows, request access async will pop up some UI, a dialog, a confirmation dialog, and this is where the user has to say, okay, I'm cool for this app to be allowed to be pinned to the lock screen. And you have to be pinned to the lock screen to run background tasks on big Windows. On Windows Phone, you still have to call this thing, but it doesn't pop up any UI. There's no user confirmation, but you still need to call it. If you don't call it, your tasks won't run, or they might in certain circumstances run, but with such minimal resources allocated to them that essentially they're going to fail. But you do need to check the status return you get back from that, because if you get background access status .denied, that means there's something stopping your background task from running. And this could be the user has turned off background execution for this app, or the maximum number of background apps across the system has been reached. So you need to put up some UI saying, oh, I want to do this cool stuff for you, but something's stopping me. And the main reason why something may be stopping you is this new app called Battery Saver, where people can see all of the apps on the system that are using their battery and also doing background execution. So this is brand new in Windows Phone 8.1, and they can sort and manage which apps can execute in the background. So they can disallow background execution through here. So this is the full code for registering a background task. You need to create a new background task builder. You give it a name, that's important. And then here's your system trigger. You can specify the different kind of trigger. Obviously, this is a system trigger. A new upper system trigger for the type of system trigger. This is a time zone change example. Then you call taskbuilder.setTrigger. So you set that trigger into that background task builder object. Then you can optionally add a condition. This one is being a condition for internet available. And then, this is very important as well, your background task builder .task entry point, you need to put the name of the class in your background task. And you can just put that in as a string, but by far the best practice is to use the way it's shown here. Type of whatever the my background task dot the task. So IntelliSense will make sure you get that right. Dot full name. So that gives you the full name of that class in your background task project. And then you call taskbuilder.register. You register your background task. And then optionally at the bottom, this is where you can hook those events that the background task fires. You can hook a progress event to get a progress update or a completed event. You can find out what background task registrations you already have, and then you can unregister them when you're done and re-register them as appropriate. And obviously, you might, if you're unregistered, you want to deregister from any events associated with that as well. The debugger can launch background tasks. So once you've actually got a project like this, you'll find a new thing on the app lifecycle menu there. Under suspend, resume, and suspend and shutdown, you'll see the name of your background task, so you can manually invoke it. All right, let's go and have a look at a quick demo of this. And this is a little solution. Keep it really simple. We've got our foreground app 10, and we've got a background task. The code in the background task. This is it. It's called the project is called My Background Task, and the class is called The Task. And as you see, it implements iBackground Task as it has to do. And then inside the run method, well, we get the deferral. Because we've got an await in the middle of it, so we need to have a deferral on either side. But even if you don't have any await stuff in there, just do it anyway and make it your normal pattern. It doesn't harm to do that, to wrap your execution code in a get deferral.complete. And then inside the background task, we've got a simple thing. This does a loop. It goes round for 10 times. It updates the progress counter, so it counts up from 0 to 10. And then we actually just simply delay the task we sleep for 2 seconds. So it simulates a long-running task. And then what it does is it writes some information into a file as well, so the foreground app can see it. Now, over in my manifest for the foreground app, we've got the declarations. And here we got, this is where you can select one. I could add another background task, but I don't want to. Oh, rubbish. I removed them both. That's bad.
No, it's still there. Right at the end.
Okay.
The entry point?
Yes.
System event entry point.
Okay, there we go.
Yeah.
So so here's the one that we've got. It's a system event because we're going to do a time zone change on it. So this is the one. It's a system event, this is the my background task.the task, which is the entry point into my background task. And then in my foreground app, I've got some. So let's run it, and then we'll look at the code in the foreground app. I don't need the. Oops. Don't need the. Not that one. This one. My goodness. Let's get rid of this code. Right. The background task isn't registered at the moment. When I click that button, we're going to go over into the code, and we're going to call the register task. So we're going to call request access async. We're going to new up our background task builder. We're going to create a system trigger of type time zone change, set the trigger, and then register it. So let's go ahead and do that. So there we go. It's now registered. We've got a progress counter, a progress bar here, but the background task isn't running. So if I now go and I'm going to just suspend the foreground app before I do this, just for reasons of this demo. So suspend it. So we're not running our foreground app, but I'm going to go over into the settings, and we're going to change the time zone of this particular phone. Oh, there we go, date and time. So where do you want to go? Hawaii.
Hawaii
nice.
Sounds fantastic.
Yeah, let's go to Hawaii. Yeah, okay. Then if we go back and restart our... yeah, I know we're already suspended. Resume our foreground app. The progress bar is halfway across because our background task is running in the background. It's doing that 2 seconds and then sending that progress thing. So it's running in the background. And it's finished, and it's also the foreground app has gone and read that from the file that it ran in to find out when it last ran. Actually, that's it. It's not super exciting, is it really?
I think it's exciting.
Oh, good. I'm glad you do. I'm glad you do. It's just a simple example that illustrates kind of how it works.
Well, I love it because there's so many cool triggers, and they have so many cool conditionals to them. That when you combine the types of triggers that you have along with the conditionals, you can do an enormous amount of things with background tasks.
Yeah, it is very powerful. Let me just walk through this one example just to wrap up of how exciting this can be. So if you can imagine, we've got an app, and maybe we're going to use this for the real football, soccer as you guys call it. And maybe you're interested in a football, that's in the way that the rest of the world talks about it, soccer score cloud service, and you're particularly interested, we're going to go through Windows notification services, and we've registered a push background task. So this is the one that fires when a raw notification comes in. You're interested in there's a match going on between Manchester City and Manchester United. So every time there's a goal scored in it, a raw notification is going to get sent through. So after 32 minutes, Yaya Toure has just scored for Manchester City. And a push notification goes through. It's just a raw one. It's XML. It goes through notification services, is intercepted by the background task, so the foreground app isn't even running, and it could pop up a toast to saying City have scored, but it will store details locally, of course, as well. So whenever the user then goes off into the app, and actually the background task could go back to the cloud service and get more data, so that when the user goes into the app, it's already updated. You've already got that latest information, and they don't have this annoying thing where they sit and watching while the app updates. And then later on, we've got an equalizer by, who should we say, Ryan Giggs. Yeah, I know he's their manager now. Okay, so they've got a goal. So another one goes through, and you can just see how the data keeps getting sent through, and the background task can be storing the updated information. It could be popping up toast, and the user's getting the information that they really like. At the end, it looks like a result for Manchester City there. So well done, the Blues. Yeah, here we go. We could pop up toasts and keep the user informed in various ways. The foreground app can then go into that storage to get all that information that's been gathered and present a full, match report to the user when they later on come along and open up the foreground app. Right, that was the good news. And now the kind of the ugly detail. The resource constraints. So all background tasks have CPU, memory, and network quotas. As Matthias mentioned right earlier, the difference is they're based on actual CPU usage instead of wall clock time. So it was wall clock time on Windows Phone 8, but now we're looking at CPU usage. So you actually get 2 seconds per app of CPU time refreshed every 15 minutes. So every 15 minutes you get a new 2 seconds quota. Doesn't sound like a lot, but actually modern processors and the speed that these things are running at, 2 seconds is not shabby at all. You can do a lot of stuff with that. Then wall clock CPU quota will also be enforced, but you're going to get at least 30 seconds. So the memory quota scales are based on the device capabilities, but the important thing to stress is you need to call request access async to get your full quota. Also, the other thing is on the low-spec devices, the 512 meg devices, the number of background apps is limited. So once you get to the bigger devices, that goes away. So again, this is another reason why you need to check the status return for request access async. Memory caps, you also got a memory cap on how much memory you can use. And they're limited by the kind of background task and the amount of physical memory the device has got. So you've got 512 megs on the left there. If you're on a 1 gig device, you get loads more, and 2 gigs, it's pretty, loads of memory actually. So you can see the quotas for the different kinds of tasks there. So just bear that in mind. Keep your processes as lean as possible so they'll run on successfully on the widest range of devices. There's a few things that don't run on Windows Phone Store apps. So these are Silverlight only, apps that run under the lock screen. The continuous background location tracking apps are Silverlight 8.0 only. And we'll talk a bit more about that tomorrow. Voice over IP agents, Silverlight only. And we've got this strange foreground agents, which are specific to the wallet, again, are Silverlight only. But that's just, it doesn't mean you can't do them, but you just can't do them in Windows runtime apps. We've got some other sessions coming up that talk about related topics. But that is me done on background tasks. Okay.
Awesome. Exciting. Yeah. And we'll actually pick that up in the next session where we talk a little bit about background tasks and in the context of geofencing and location.
Okay. We'll see you in a few minutes.
So.